You know how it is. Hello and welcome back to Statistics 1. Section 6.2, time to learn to use z-scores, area under the curve. This section is mechanics only, and then in the next section we're going to put that in a context of what we did last class. So today we are going to look at 3 cases and learn to compute values. So first case would be when you have a z-score and you look up area to the left. Then we will consider the case where you look up a z-score and then read the area to the right. And finally, we take a look at 2 z-scores that give us area in between. So these are the 3 cases, and as I said, today is just the calculation. I mean, this lecture is just calculation, and then we're going to apply that to approximate to normal height, to IQ, and all of the other things that we might be interested in. First off, when you look at the z-score chart, particularly in the back of the book, usually the charts that are in the book will have 2 charts. One will have a graph that looks, it's a bad graph. So, you know what? I'm going to make this much larger. There we go. So, usually, you will have this. And then that. There we go. Which is, in your case, at the back of your textbook. It's divided into these 2 charts. And first note that both of these are area to the left. And I put that in blood over here. Both are area to the left. What happened? That's Dan Rodorak. Change his last name because we're so cool. Alright? Alright, so what do we have? We have a z-score chart that will have negative z-scores on the left and positive z-scores to the right. And the z-scores are going to be in these margins. So I'll put a bunch of z's over here, and I'll put a bunch of a's in the middle. So this is what your chart looks like, and then you have the same thing on the other side. And I'll put a whole bunch of z's. Cross your z's, right? These are not 2's. So a whole bunch of z's. So these margins give you z-scores and a whole bunch of a's as areas in the middle. So now in here is your whole number and first decimal, and here is your second decimal. And the same goes for the other side, obviously. So all z-scores are given as a number, dot, digit, digit. Nah, it looks like a Morse code. 2.18 is a z-score. So you have your so these are the rows, and this single one is a column. That's the way the z-scores work. There is a cut here. So now, when I switch to the z-score chart, we see that we can locate any z-score from negative 3.4 to positive 3.4. Now, what do we know? Z-scores are standard deviations. We also know that 99.7% of all data and everything we do falls within those three standard deviations to the left or the right. And this goes all the way to 3.4, so this is great, right? The z-score, let's say, is negative 1.92. Okay, we cut off the 2, and we look for the row with negative 1.9. Well, that's here. Negative 1.9 row, right in the middle of the chart, negative 1.9. And then we look up to find the decimal 2, because that's the last digit over here. So that is in our third column of numbers, or the fourth column altogether. And they meet at the value of 0.0274. So z-score of negative 1.92 gives an area to the left of 0.0274. That's the way we read the chart. We will be calculating z-scores using the formula we learned earlier, and then you look at the chart now, some of the z-scores, because we're using them so much. You will actually memorize these values just because you come to class and you do the homework, do the online stuff. You will actually memorize 5 or 6 of these areas for some of the z-scores that pretty much show up all the time. And you will see by the end of the course what those values are. It's not mandatory, it just happens because you are cognitively evolved for like 5 seconds. So, z-score of 2.36. Well, you are not going to find a positive z-score on the negative chart. So common sense says, look at the positive side of z-scores. So we move to the positive chart, and we look for 2.3 row, 2.3 row, and then for the 6 on the decimal. So follow blue to this one, and we get that the area is 0.988.
0.9909. Yeah.
That's what I said, please pay attention. 0.9909. 0.9909. 09.
That's the area of what under the...
That's the area under the curve because you are going to, well, I'm going to do that. So this is where your 0 is. This is 1, this is 2, this is 3, this is your 236. So all of this area, area under the standard normal curve is 1. So this is 99% of the area, and then only 1% area this way.
So what exactly is the area of the box?
That's the next lecture. It gives you percentage. So if your IQ is at the 2.36, that means that you're smarter than 90%, 99% of people. So it means. We'll get it. So now let's take a look at these examples. And then obviously, right, we're going to add some mathematical gymnastics, which is area to the right, area in between. This is only mechanics of calculations, and then we'll do the word problems and the meaning in 6.3, which is also today. So let's jump into first giving these area to the left, and we said the z-score of negative 1.92 gave the area of 0.0274 when we looked at the chart. Z-score of 2.36 gave us the area of 0.9909. Now, on the picture, the graph, 0, -1, -2, -3. This is almost -2. Area to the 1. And so area under the curve is 1. So having the most of the stuff shaded to the left, most of the areas shaded to the left, says, yeah, it makes sense to have 0.99. Now, what do we do for area to the right? Excellent. So area, I can write as a formula. Area to the right is going to be 1, it's number 1, minus the area to the left. So now, find area to the right of z equals 1.12, for instance. So in order for us to find the area to the right, remember our chart only reads left. In order for us to find area to the right, we will have to find area to the left, which is what we don't want, and then subtract that from 1 to get the area to the right, which is the red shade, which is what we do want. So we first find the area to the left by going to our chart and looking at positive side for 1.12. So 1.12 is all 8s, right? Oh, it's not 2, 2, it's 1, 1, 2. Okay, yes, you're right. 0.8686, 0.8686, 0.8686, and now area to the right is 1 minus 0.8686, which is equal to 0.1314. So that's the way to find area to the right. Now, area to the right has a z-score associated with z alpha. So the symbol z alpha is used to denote the z-score that has an area of alpha to the right of the standard, the curve. So z alpha, alpha is the Greek, first letter of Greek alphabet comparable to A that we have in Latin. So that gives us area which is called alpha, which is area to the right. So this is a notation. So technically I need to put alpha over there in a problem. Find the area to the right of z alpha. So yeah, the notation, but again, that's what you're learning, right? So if you see z only, then it's looking for area to the left. If you see z alpha, it's looking for area to the right. It's worthwhile writing. Let's go. So z, look for area to the left. Z alpha, look for the area to the right. And that takes care of that. Great. So now I have all of those, and the next order of business is to, well, let's do one more because we can. So how about z alpha is equal to negative 0.36. I can literally put whatever. So we always use 2 decimals for z and 4 for the area. So z alpha is equal to this. We're looking for alpha, which is the area to the right. So that's area to the right. And it's going to be 1 minus whatever we find for negative 0.36. Can you tell me which number I should use? Now negative, so we have to be on the left chart. Just read it. 3594, thank you. 0.3594, which gives us 0.6406. Good. The last piece of this mechanics is to find the area between Z1 and Z2, because you might want to know what is the percent of people whose height is between 5 and 6 feet, right? You have those that are 6'1", 6'2", but you have also people that are 4'8", 4'9", 4'10", right? You just want to know what is the percent of people whose height is between the two. So we would like to have now 2 z-scores, Z1 and Z2, and look for the area in between. So how would we do that? Any ideas? Area of Z2 minus the area of Z1. Very good. It's the concept of eating a banana. You throw away the peel, right? When you have a banana, you have the whole thing, which is the peel and the banana that you want to eat, right? So you throw away the peel, and then you just have the banana left. So to find this area, it's going to be area 2 minus area 1. Area 2 came from Z2, area 1 came from Z1. So let's see. Let Z1 be negative 0.84 and a Z2 be 1.63. So that means that area 1 is on the left chart, negative 0.84. $20.05. And area 2, which is on the right, we have to move the chart to the right. 163. 163. 9484. And now we subtract these two numbers. Area is going to be 0.9484 minus 0.2008. This is equal to 0.7476. Two zeros and a 5. Then this is going to be a 9 over here. Hello. Oh, thank you. All right, one more example, and then we're going to go to the next lecture where we actually use this stuff. So let Z1 be negative 0.14 and Z2 be, let's just use 0. So what's A1? And if you say it's steak sauce, I heard that before. Ha ha. So what's A1? Four. 3 4s and then a 3? All right. And what's A2? What's A2? Has to be 0.5, right? It's 0 is in dead center. 0 is in the dead center of the chart. That's the z-score of 0. That's the mean of the chart. So it has exactly half area to the left and half area to the right, so it's 0.5. So now when you subtract this, 0.5 minus 0.4443, you'll get 0.0007. No, I lied. 557. 0.0557. So let's deal with more of this cool stuff. What's the z-score if the area is equal to 0.6394? What's the area if the z-score is 0.6394? Now, before you even go and look for a number, are you expecting negative or positive z-score? I'll keep my poker face no matter what you say until you give me the reason why you would expect either negative or positive. Yes? Yes. But then what do we know if a z-score is 0? What was the area? 0.5. And this area is which is more than 0.5, which means it has to come from positive z-score, right? So we're going to go and stare at the chart until we find the closest number to 0.6394. 6394. So we have the choice between 6368, 6368, and 6408? 06? Okay. Now, which one is closer to 94? Is 94 closer to 68 or 06? It's closer to 06. So we will use that one. I'll just do this and say closer. And this one gives us what z-score when you read on the sides. Yep, 036. 036. So if you are given an area, then you can actually find the z-score. If you're given z-score, you can find an area. You have the chart, and chart will go both ways. And you will know from the problem, when you get your word problems in the next section, you will know which way you need to read. Just need to be able to read both ways. Now, clearly, it's much easier to get areas from z's than z's from areas, because you have to play this game of what fits the best and what's the closest. And if they are the same amount away from the two numbers, two z-scores, you take the average of two z-scores, in which case your z-score will have three decimals, but that's rare. Let's take a look at the homework assignment. Homework assignment is asking you to find the area and the two, what we call tail ends. So two tails, and each one of these is a 233 as a z-score. Now you can exploit symmetry here, it's fine, right? What does that mean? They're balanced on both sides, so what do I need to calculate? Just one side and then times 2. Great. So we're going to go to the chart, and for z equals negative 2.33, we're going to find the area for negative 233. What do you guys have? I got 0099. Are we good? All right. So now, that's only one. So now area we are looking for is 2 times this. So I'll just say area to the left, let's say. Is 2 times 0.0099, which will give us 0.0198. And that would be area they're looking for. This is the homework example 6.667b. 6.67b. Okay, now let's take a look at determine the z. So this is another homework exercise, 6.77. It says determine z of 0.33. Now, we know that this information is actually, I'll put this different color. This is what you need to know, is Z alpha. So what are they looking for? What are they looking for? Area to the right. So if you draw your bell-shaped curve, it's disgusting. So 0.33, 0 is in the middle, and then you have your 1, 2, and 3 standard deviations. 0.33 is about there. And they are looking for area to the right because the notation was the one that told us there is alpha involved, right? So the area we're looking for is 1 minus, we're looking for alpha, right? Area to the right. So alpha is 1 minus the area to the left. So 1 minus, and now we go 0.33. 0.33. 6293. And the area that they are looking for, alpha, is equal to 0.3707. That's it. No. Because other z's are, all other z's that we see are z equals 0.63, z equals negative 0 or 1 point, let's say 1.62, and so z of 0.19, right? That reminds of this one. So we only had that for the area to the right. So that's, and I think actually I did have in purple, there it is, right? So regular z, right, z equals, gives us that, and then z sub alpha is area to the right. That's it. That's those are the mechanics. So we get to look for area to the left, which is what is in the chart, area to the right, 1 minus left, area in between, bigger minus smaller, and then these two end ones, where you can just calculate if it's symmetric, calculate 1, and then multiply by 2, because it's symmetric and these areas here are the same, which is why we multiply by 2. Do they have to be the same? No, it just gives you more headache than to calculate. Do they have a problem like that? Of course they do. Problem 666. Convenient, huh? Either, so they're giving you two z-scores. They're giving you -1 z-score and 2. And they want area like that. So there are two ways in which you can calculate this, but let me see what you guys are going to come up with before I step in. Yeah, are you disappointed? All right, so there are two ways. One way would be to find area in between and then subtract from 1. And the other way would be to find this area directly from the chart and then this area minus 1 and then add the two areas. So there are two ways. Let's go with, let's say, way 1. Would be to find the area to the left for z-score of -1. So that area for -1 is 1587. Then z of 2. You see the notation? It's kind of bad notation, but that's what it is. So alpha is 1 minus z for 2, which is 0.228, which is 0.0772. And now the area we're looking for is to simply add these two numbers. So 0.1587, which is the area on the left shade, plus 0.772, which is the right shade, and we will get, there's a 0 missing, okay, good. So 0.2359. So that's one way. The other way, way 2,
you did the wrong one for Z2. The 0.0228 is what you get after subtracting 1 from 97.
oh, I looked at the wrong, I looked at the -2. Yep. 0.0228, and this is supposed to be 9772. So this is 0.228, and the answer is 0.1805, right? 15. 1815. Now let's do way 2. Way 2 will calculate area in between and then 1 minus. So area would be 1 minus area between -1 and 2. So we find the z-score, which is to the left of, so z-score -1 is 1587. Then we find the z-score for 2 to the left, which is 9772. And then we find area in between, which is when we subtract 0. So when I subtract, that's going to be 2 minus 7 is 5, still 1, so this is 6 minus 8 is 8, still 1 is 6, and then 1 is 8. And now area we're looking for, these are all area 1, area 2, area in between, and area we're looking for is 1 minus area in between, which is 1 minus 0.8685, which gives us 1.8. 5 and then 1 and then 9 minus this is 3. I'm not getting the same answer. Something is off. $15.87, good. 9,772. Okay, so now let's see. 9,772 minus 1587. Yeah, it's 81, and now that turns into 8. They have to match because it's just two ways to get the same calculation. So those were the homework exercises, and now we'll switch to the next lecture to see the use of this in word problems. So let's restart this.